are going to do Atterberg limit test today, and so as we already described, now if you look at the moisture content versus volume relationship, you can see that there's a flat region and then it increases linearly with the moisture content. So we define these limits very arbitrarily, right? So for example, now this is the region where it is behaving like a solid, and then it is behaving like a semi-solid in this region, and then the plastic region, and the liquid, it will flow like a liquid. So we define these moisture contents corresponding to different regions. So this is a very arbitrary definition, so therefore we have to do the test accordingly, very accurately according to a given standard. Now the standard used here is ASTM D4318. So you have to prepare the sample according to that, and then carry out the test according to that, and then analyze the data to get the results. Now so what we do initially is that we have the soil sample here, and then we sieve it through number 40 sieve. So this is should not be oven dried, and we can air dry the soil here, and then sieve it through this number 40 sieve. Number 40 sieve opening is 0.425 millimeter opening here, right? So we sieve through this and then prepare the sample like this. So we take a portion of that and carry out the test. So that's how we prepare the sample. So if I explain to you regarding the equipment used for the liquid limit apparatus, now this is the apparatus used for the liquid limit test. As you can see, there's a brass cup here, and this cup should be very well clean. And also, now when you crank this bar, this will be raised, this cup will be raised and will be dropped exactly 10 millimeters. So we have to first check using this particular brass solid whether this is exactly 10 millimeters. So if it is not 10 millimeters, then we can adjust that height using this particular screw, and the number of blows will be counted, will be indicated here, right? So later we'll do a demonstration. The important thing is that this cup should be very well cleaned, and this height of drop should be exactly 10 millimeters. And also immediately after you put the soil pad in here, right? So you have to start doing the testing. Otherwise what will happen is the sample will be dried out, and that will affect the results. So I will invite Hashini to demonstrate the testing according to the standard here, and so she will demonstrate, and later on I will again come back and show you how to do the calculation.
Okay, so today we are here to do the Atterberg limit test. So for that we need to have a soil sample that is sieved through sieve number 40, which we have already done. And we have taken a different container. We will add around 100 grams of the soil sample to a different container. And we need to add some distilled water, which we have brought here, in order to make a uniform paste. So after you add a certain amount of water, you may stir it a little and try to make a uniform paste. Now we have prepared the sample, as you can see. Now we need to transfer this sample into this apparatus, and we need to make it horizontal and cut a groove. So for that purpose we have two tools. One is the wedge tool and the other one is the grooving tool. So we are going to transfer the soil sample into the apparatus. Okay, so we have taken the soil sample and kept it on this apparatus, and now you can see it is horizontal and the surface is very smoothly made. So now we need to cut a groove using this wedge tool. So for that purpose, you have to hold it in such a manner that it is perpendicular to the cup. So now I'm going to cut a groove. You can keep your finger like this. Make sure it is kept so you need to be able to see the cup through the cut. And now we will take the blow count for the liquid limit. So as you can see, we are operating this for 2 revolutions per second, and here it has you can see the display, the amount of blows, right? So it already has a particular number, so from this amount you can calculate, or else you can calibrate this into 0 and continue reading. So you can see the blow count is already displayed, so every time you don't need to calibrate it to 0. So from here onwards you may count the number of blows. So for this we are going to turn this 2 revolutions per second. Okay, so we need to stop the blow count as the 2 sides of the soil sample have come together. Around ½ an inch is enough. So as you can see, earlier we had a display of 108. Now the blow count is displayed in 241. So the difference will give you the blow count, right? So after this we need to take some sample for the moisture content determination. So for that we have an empty can. So you need to take the weight of this empty can, and as soon as you finish the number of blow count, you may take some sample and add it to this container and take the weight again. So this will give you the weight of the empty can plus weight of the wet soil. So after this you need to keep it in the oven for around 24 hours and take the weight again. So this will give you the weight of the empty can and the weight of the dry soil. So we have already recorded the weight of the empty can. So quickly we will take some soil sample and measure the weight of the empty can plus the weight of the wet soil. Okay, so we have done one of the trials. So likewise, similarly, you will have to do another 5 more trials to complete this experiment. So for that matter, you can use some distilled water, and for the amount of soil sample, you can add and vary the amount of distilled water you add and make the uniform paste and do the same procedure as it goes. And the blow count should be from 10 to 50. So you can take around 5 readings and continue with the rest of the calculation. Now we are going to determine the plastic limit. So in order to do that, we have some soil sample with a little moisture added. So we will have to take peanut size balls, right, onto a glass plate, and using your palm you may make threads. So each thread you make should be around 3 millimeter in size. So as you can see, there are some cracks formed. So when these cracks appear, you may stop rolling. So we have, like similarly, we have done for 3 of these threads which are of 3 millimeter diameter, and they are all uniform. So now we will have to determine the moisture content. So all these 3 can be kept in one container. So we have already recorded the weight of this empty container. So you may keep all these 3 samples in one and record the weight. And after 24 hours, you may take the weight again and see the moisture content. So likewise, we will have to do this for another 2 trials for the plastic limit determination.